Hello, my name is Sunil Amin, and I'm a principal engineer at Cisco Systems. I've spent the last 17 years working on advanced analytics in the domain of security detections. And today's talk is going to be about practical applications and best practices for machine learning. I think a couple of weeks ago, a colleague of mine presented a short talk on the fundamentals of machine learning, and today's talk is really going to go beyond just the techniques and talk about how they can be used, where they should be used, sort of things that you should be looking out for when selecting these technologies, and some anecdotes that probably help you along the way. So machine learning, separating fact from fiction. Well, the fact is we kind of shot ourselves a foot a little bit here by over marketing some of the terminology and some of the outcomes that machine learning gets us. And us as vendors, we got us here and we have to put our hands up and say so. You know, we've had marketing that make really broad, bold statements like advanced threats are no match for AI, or our machines detect threats that others cannot, and making claims about predictions. And the fact is a lot of this marketing hype has really kind of confused both the end user and frankly some of the vendors as well. And as this slide points out, this is really a disservice to machine learning, because as we'll see, it has its uses, it has its places, it has its value, but we've kind of overhyped it through the silver bullet marketing. And this key thing in the middle here, no explanation or discussion, and that's kind of that black box sort of approach to saying, well, here's the machine learning, it's always right, and then limited guidance from vendors and the market in general on how we select such tools. The key thing about machine learning and kind of how we start to get through all of the hype is to understand that one size does not fit all. And what I'm saying there is that just because a machine learning application in one domain has worked successfully doesn't mean that same application, those same techniques, those same approaches work for security. And that's okay. This is not new to us. So let's go next to understanding the forms and functions of machine learning and kind of give ourselves some context so that we can build up a level of understanding that allows us to select the best tool for the best job. And just repeating something that you may have seen in other presentations, we really want to point out some of the terminology and how they relate to each other. Machine learning is a subset of artificial intelligence, but therefore not all artificial intelligence is machine learning. And that's really the big picture of AI and ML, and making sure that you understand that context and the concentric ring. But even within machine learning, there are lots of terminology and techniques that are commonly espoused, and you should understand their relationship. So kind of the ones you would hear about the most often are supervised learning and unsupervised learning, but there also exists this third kind of leg called reinforcement learning, and all of these techniques have applicability in any given domain as long as you know how to wield it, and that's where the expertise comes in. You really need to understand what they're good at, what they're not good at, and understand how that relates to the domain. And often that gets kind of lost in our conversation. I'm not going to go to the actual individual techniques themselves and how they relate. There are plenty of other talks and material out there that can explain that. But one thing that's kind of interesting to look at is how often each of those techniques are used within the security domain. And these statistics really kind of bear that out, that most of the time when security vendors are talking about machine learning, they're talking about supervised learning. And that's the process of training a machine offline and then dropping that machine into an environment and then allowing it using a offline experience to make inferences about the current situation. Unsupervised learning is not used as often. In fact, it pales in significance, but really is the one where you have no a priori knowledge and you're looking for patterns and clusters of behaviors and of features in the new environment. So with that in mind, you know, when we apply machine learning, we often have to ask ourselves, you know, how do we know that the machine learning is actually working? Now, in the mathematical realm, that is machine learning, there are two very, very specific measures that are used specifically around supervised learning called accuracy and provision. Accuracy is how often does my classifier give me the correct answer? And precision is when my classifier predicts an instance in a certain class, how often does the instance belong to that class? And out of these two things come terms like false positive, true positive, and everything mathematically related to that. Now, I wanted to qualify that in saying that these are almost overwhelmingly applied to supervised learning, where you have an a priori knowledge. That means that somewhere you have a set of data that represents some form of truth, and that you're able to compare against that. And that's key, because without that comparison, without that denominator, you're not going to be able to put a number on the accuracy and precision of the work that's in front of you. So moving on from those mathematical kind of measures, let's talk about how we do apply machine learning security and where it might work effectively, and how you might go about kind of sifting the marketing hype from the reality. So why do we think machine learning is so useful in security? Why do we think it's worth all the hype or getting past the hype to actually understand it? And that's because we live in an evolving security world, not a static world. You know, the way the attackers and the malicious guys, the bad guys, are approaching their job is continuously evolving. If the domain that we were in, so security domain, was completely static and could be described, we could get away with signatures and rules, and would be able to do all of our work there. For example, we can identify most web browsers using a signature-based system that looks at the first TLS packet sent, and that would be the static world. But the fact is, we know that we don't live in a static world. Both the attacker is evolving, the environments they're targeting are evolving, and all of the software machines within those environments are constantly evolving. So as such, our domain, the security domain, is evolving, has a large amount of variability, or is not well understood. And that's where machine learning really comes into its own. It can help us, the humans, understand the domain and efficiently make predictions of unseen instances. When it comes to insider threats and behavioral security analytics, we're really talking about the evolving nature of the security threat, the ones that evolve the fastest, the ones that can't be written, where you can't write signatures of rule against. And from an attacker's perspective, they're not breaking in, they're logging in. So, in a lot of cases, there are no pieces of software, there's no malware, there are no lists of, malicious software hashes that you can go match against the list. Detecting through novelty and outliers is the technique where you're looking for those things that you haven't seen before, and could indicate the genesis of a detected threat. So a novel peer relationship is established, a novel volume of traffic is seen, a novel protocol is used, a novel time or location is seen in a particular type of behavior. And then the events can be aggregated, so we can aggregate their findings into indexes or point systems that kind of rank things. Lots of weak signals can be transformed or combined into a strong signal that allows us to see above the noise. Another way of looking at that process is described in this diagram, where you've got this thing called feature printing. That's just a term that we use, which is an additional method to label and help classification and categorization, some form of labeling. And through that, you can then use those labels to track and understand the behavioral model of any particular part of the domain, whether it's a machine or a user or any asset in your environment. And only at that point can you apply this thing called behavioral analytics, and I'll get into that in a second. But I just wanted to point out this flow, because guess one of those best practices to understand that where all of those pieces live in the tooling that you have, and that you have all those pieces. Because really, if any one of these pieces is missing, you're really not getting the best out of the system. Just to be really, really concrete, when it comes to behavioral detection and then behavioral analysis, we're really contrasting against signature and rule-based system. With a signature-based system, it's very clearly if I see this pattern, then ring the bell, sound the alarm, versus the behavioral side of things, where it's, I've observed that a set of actions perform, and then I sound the alarm. So a set of actions being the key words, as opposed to just simple pattern matching. And kind of a real world example goes something like this. And frankly, I've stolen this from a colleague of mine, but it's an extremely good explanatory device. So here we have a picture of a chef's knife. We know what this is from its features. Features being its shape, its length, the type of handle it has. It's got a blade that's being used for food preparation in kitchens. It's a blade of a particular shape, has a handle, has a particular weight. And even the name itself suggests to us what its behaviors might be. However, that very same knife could have a set of other behaviors that are not expected or unusual or straight out malicious. For example, behavior 1, on Monday night, a chef used this knife to prepare a meal. Okay, so that's the one we know. Behavior 2, on Tuesday, it was used as a murder weapon. Certainly not something you would expect it to be used. We know it could be used for that, but it's definitely a behavior that falls outside what we would consider normal. And then a more interesting one on behavior 3, on Tuesday night, a passenger was removed from a flight because this object is not out on an airplane. It wasn't even being used to cut anything, but it had a behavior associated with it. And so this is a good example of, if we had just pattern matched, we would have just come up with the conclusion that this is a chef's knife. But by observing the actions and the set of actions, we can go further than that and use behavior analysis to determine that it was used in as a murder weapon or was an illegal object on a plane. And when you consider those behaviors, we can classify the observable world and infer the rest, and that's really important. So, known bad, that's knife used as murder weapon. We know that to be bad, and that's your threat activity. We can use our expertise and the data we collect to block that out. We can also do some sort of analysis on normal activity. That's your business policies, what is acceptable behavior from your employees or your machines, and call that a normal activity. And after you've blocked those off, you've got everything else in between. Weird stuff, sometimes it's called, not necessarily threat related. Some of it could be, definitely in my experience, it could be things like misconfigurations or new applications or unknown behavior that was unknown to that point. But actually, bringing it to the front is really important, and you can definitely train on with examples and start kind of bounding these out. When it comes to machine learning itself and the actual techniques and how you apply it to achieve these behavioral detections that I described, there are certainly areas where the hype is actually deserved. And in our experience, when it came to actually implementing these in production, we actually went from multi-layer analytic pipeline, multiple layers of analysis, not just machine learning, but then even within machine learning, many layers of machine learning algorithms combined in a pipeline. And on the left there, you kind of have the funnel coming in with lots and lots of data. In our case, it's lots of data around network connections. And then going through this funnel and then reducing the data set to yield kind of the outcome we want at the very far right end. And at each stage, we're using lots and lots of techniques. And that's something that we've learned through experience as we drove to improve the overall efficacy of the system, as well as using it in and itself as a barrier to adversarial techniques coming from the bad guys. And adversarial techniques, a bit of a sidebar there, it's probably a talk on in itself, is a way a malicious actor can feed data into any machine learning system or even artificial intelligence system to fool it into thinking that it's one outcome versus the other. And we really want to pay attention to that, because as our detection systems become more sophisticated, so is the attacker's approach. So in this particular case, we have used layers and layers and layers upon of techniques. The premise being that an attacker could probably work out how to get past one or two of these, but not getting past all of them. And then once you've kind of understood behavioral anomaly detection and how that can work for security, and then you understand the techniques that can be applied to achieve that, the very last thing we need to do is kind of measure the right things. How do we measure success? How do we know we're doing well? How do we know the system's doing what we want it to do? Now, at the top of the talk, I talked about accuracy and precision, and that leads to a lot of mathematical numerical values that can be mathematically derived and attached to a system, things like true and false positive, or the overfitting or the underfitting, and other things like error. And these are all great, and these are should be used heavily in the research and development phase, especially when it comes to supervised learning or anything that is dealing with a ground truth. However, reality is not just that. Some of these numbers may work well in the lab, but how do they work in the real world? What is the qualitative measure of the outcomes that we're seeking at? And how do we as humans sit in front of a screen and decide whether the machine is doing something useful? Well, within my own work and the work of my team, we've tried many things to work out a measure that we can use to kind of measure our success. And what we actually landed on is something that might seem super subjective, but it's simply this dialogue. And this has popped up in our system every time one of these analytical outcomes are shown to a user. In the case of this particular product, it's here's an alert based on behavioral observations. And it's a simple question: was this alert helpful? And that's really asking that person in front of the screen subjectively if it was helpful. It's not asking if this was a false positive or a true positive, because that would go to kind of understand, trying to guess whether or not the thing you've just proposed to the user is actually useful. That would be a guess on our part. This is very explicit. This tells us if the alerts are actually helpful. Again, not trying to say whether it's benign or malicious, but just was it helpful to the user. Now, what that means is that we're able to track the statistics for every outcome that we have in our products, and we're actually shooting for 95% plus. If anything falls below that, then that's really a trigger for our R&D teams to go back and look at the data and the approach and start moving things around to make it better. But yeah, we're always looking for these numbers, and we've just found this to be an incredibly useful tool. So, machine learning, some conclusions, some key takeaways from the talk that I've just given. Let's start with, how are you applying machine learning in your product and why? So this is what you ask your vendor when you're assessing the security tools that are put in front of you and you're trying to get past all that marketing hype. And then how do you measure its effectiveness? Again, mathematical rates, numbers that are developed in abstract are one way of measuring success, but I will posit that the helpfulness of the outcomes to you, the user, is the more important thing. And so that's definitely something to ask, whether they have subjective or objective measures of the effectiveness of the machine learning in the product. And one really key thing here, which is kind of there implied, is the and why. So machine learning is not a silver bullet. Just because something has machine learning doesn't mean that it's necessarily better for you in getting the outcomes you want. It may well be that a pattern-based or a signature-based or a rule-based system could get you 99% of the way there. So you've got to ask yourself, why is there machine learning even there? What is it trying to solve that some other traditional technique couldn't solve? When it comes to supervised learning, what are you using for ground truth? And that's important. I alluded to it earlier that a lot of the measures around false positive rates or true positive rates are really kind of targeted towards systems where you do have a ground truth. And then you've got to ask yourself, what are the ground truths they're using? Are those ground truths biased in any way, or how are they avoiding bias? Because at the end of the day, when you train something offline, you've got to be as representative as possible in your ground truth, so that when it's in production and it's seen something it hasn't seen before, that is able to the best of its ability, give you the right answers. So, where are those vendors getting their ground truth? Do they have a robust data collection, ground truth collection system? And again, in security, that's, you've got to think, that's quite hard. In security, a ground truth would literally be recording of an in-progress attack or an in-progress breach. And so you got to ask yourself, how do you create that, and how do you train on that? And then what non-machine learning are you using and why? And that's the corollary of the earlier question, but completely valid, right? If all our security products only use machine learning, I don't know that would be happy with that. So again, it's probably good to ask, what are the non-machine learning techniques you're using and where are they applied? Again, back to the multi-layer analysis system that we came up with. It uses everything and anything that is necessary to get us the best outcome. We're not just tied to machine learning. And finally, just a bit of an entailment trail on the work that's the guys, the people you're talking to are doing. What papers and open source have you published regarding your analytics? Definitely within Cisco, we're big on this. We want to present and share with the world. We want other eyes on our research and get that feedback in, and that's really important. We definitely engage with the academic community around the work we do, and we find that it's a very fruitful relationship. And then finally, for the ML-based assertion, what entailments provided? Now, I haven't really talked much about this, but when the machine learning is providing assertions to you, what explanations are associated with it? What's coming out of the machine that explains why that particular answer was reached? And that's really important, because if the machine learning in my online TV streaming platform recommends something I don't really like, that's okay, it's not a big deal. But if the machine learning is recommending that I wipe the CEO's laptop, well, you know what? I think we should have some entailment. I need to know why. It needs to be documented, and I probably need to share that with my colleagues before I do anything that's drastic. And then finally, kind of a checklist on a good machine learning approach. Be pragmatic, not dogmatic. You don't have to just use machine learning. In fact, I recommend that you don't. Look for those entailments. Make sure the system is providing some sort of explanation as to why it drew the conclusion it drew. Analytic pipelines over single techniques. Anything that you see that smells of a single technique, you've got to ask your question of, is that sufficient? How could an adversary circumvent it? And why other techniques aren't being used, frankly. And then success is domain specific. Just because machine learning has worked well in another industry and another domain using a particular technique, there's nothing to say that it would work well for you in security. And that's something to disambiguate very early on. And then finally, measure helpfulness, not mathematical accuracy. Again, I've gone on about this at no length during this talk, but really we have found this after years of searching for kind of the best measure, found the subjective helpfulness measure to be the one that is most successful in guiding us in our research and development towards more successful and more improved outcomes for our customers. And that there concludes my talk. Thank you so much for listening, and I really appreciate you spending the time with me today.